Okay, I just wanted to make one more quick little review video. We've already talked about integrals and areas between curves and under curves and revolutions of solids and cross sections. There's one more thing that you went over in Calc 1 that we're definitely going to use in this class, and it's L'Hopital's rule, or L'Hospital's rule, but L'Hopital's rule. And again, I'm sure you've all seen this before, but just as a quick little review, it's for when you're taking limits. And suppose I want to take the limit as x approaches, we'll do a simple one, as x approaches 2 of x squared minus 4 over x minus 2. And we know the first trick to getting the limit is to plug in the value of x equal to 2. If I do that here, I get 2 squared, 4 minus 4, which is 0, over 2 minus 2, 0, which is indeterminate and it doesn't work. One way you learn to solve this particular one in Calc 1 is to factor it. And if we factor that, we get x plus 2 over x minus 2 all over x minus 2. These factors cancel, I'm left with x plus 2. Now I plug in 2 again, and I get the limit as x approaches 2 is 2 plus 2, which is equal to 4. And that's one way to do it. The other trick, once you learn what derivatives are, is L'Hopital's rule. And the idea is, if you have an indeterminate form, something like 0 over 0 or infinity over infinity, you can apply L'Hopital's rule to it. And the way it works is, you take the derivative of the top function and the derivative of the bottom function individually and then apply the limit again. Meaning here, I take the derivative of the top, I'll just get 2x. I take the derivative of the bottom, which is 1. Now, I apply the limit again. The limit as x approaches 2 of 2x over 1, if I plug in 2, I get 4. And we see I get the same in both ways, so it works well. I'm not going to bother with the proof of L'Hopital's or anything like that, because again, this is just a quick review. But the idea is, L'Hopital's rule just gives us another way to calculate limits, and occasionally this algebra can be a little bit cumbersome. So L'Hopital's allows us to shortcut that, and in this class later in the semester, we will be spending some time taking limits of functions. And in order to take limits, having shortcuts like L'Hopital's are beneficial, so I want to make sure you remember it and can work through it. Really quickly, just do 1 or 2 more examples. If I have, let's see, x cubed plus 6x squared plus 9x plus 1 all over x to the 4th plus 5x cubed plus 9. And I want to take the limit as x approaches infinity in this case. If I just plug in x equal to infinity, it's not a number, but we can still use it as an idea. I get infinity plus infinity plus infinity plus 1, that's infinity, over infinity plus 9, which is infinity. And I get another one of my indeterminate forms. And then I have to figure out what to do. And again, I would actually stress, if you recall from pre-calc, that's a rational function, and the degree on top is 3, the degree on bottom is 4, and the trick you learn in pre-calc is you will get a horizontal or oblique asymptote based on the degrees here, and in this case, since the degree on the top is less than the degree on the bottom, you'll get a horizontal asymptote at y equals 0, which in calculus 1 you learn that horizontal or oblique asymptote is actually your limit. So in this case, since I'll get a horizontal asymptote at 0, it actually means that my limit should equal 0. But that's kind of hand waving a little bit and not really doing any algebra. The algebraic or calculus way to do this that's indeterminate, is apply L'Hopital. So I take the derivative, I get 3x squared plus 12x plus 9 all over 4x cubed plus 15x squared. And I do stress, the other reason I'm doing this, for those of you who have not done a lot of L'Hopitals, remember you don't do the quotient rule here. You treat this as function f over function g, and you differentiate each of them individually. Differentiate that and differentiate that. Then I plug in infinity again, infinity plus 9 over infinity plus infinity. That's infinity over infinity, so it's still indeterminate. But since it's still indeterminate, I can apply L'Hopitals again. And I do it again. And I get 6x plus 12 over 12x squared plus 30x. And then I plug in x equal to infinity again, and I get infinity over infinity. But again, it's indeterminate. So again, I can just apply L'Hopitals to this. And then I get 6 over 24x plus 30, which now if I plug in x equal to infinity, I get 6 over infinity, which we know is 0. And I get the limit I know that I should. So again, if you've done L'Hopitals before, we understand if I start with an indeterminate form and apply L'Hopitals and get another indeterminate form, I can just keep on going. Until I get a form that is non-indeterminate, then L'Hopitals doesn't apply. Normally, that means I'll actually get the limit. Occasionally, you'll end up getting a limit that doesn't exist if it's where the function is undefined and it's approaching infinity. Like a vertical asymptote if you think about rational functions. But yes, the last thing maybe, suppose I want to find the limit as x approaches infinity of 1 plus 1 over x to the x. If I plug in infinity, I get 1 plus 1 over infinity to the infinity. But, well, that approaches 0, so this approaches 1, but it's not 1 because you're always adding to it. And then it's being raised to infinity. And if you have something bigger than 1 raised to infinity, it should be getting bigger, but does it? And what's the limit? This is actually a standard problem that I like for L'Hopitals, and I'm deliberately not going to answer it here because it's actually one that I like doing that you probably saw in Calc 1. If you figure it out, feel free to email me your response or stop by my office and work out the solution. If you have a question, email me or ask. Yes, this is my way to check and see if you're actually watching these videos. And let me know. But like I said, this one, it is dissimilar from most of the ones we will see in this class. But it's a standard L'Hopitals problem that I like. So see if you can come up with the answer. This is pretty much the end of all the Calc 1 review stuff that we need. If there are other things that randomly pop up as we're going through this that I think we need to recall from Calc 1 or from Traeger Pre-Calc, I'll make videos or something like that to make sure we're all clear on everything we need. But now we get to start the actual Calc 2 material.